Hi and welcome to Pre-Calc 20 with Miss Verity. Today we're going to be looking at 5.3a, dividing radicals by rationalizing. So similar to multiplying radicals, dividing, you can divide coefficients with coefficients and radicals with radicals. So looking at our first example, we've got root of 8 over root of 2. Well, if we divided each of those by 2, or 8 divided by 2 would give us 4. So we'd be left with the root of 4. Well, and the square root of 4 is 2. So that would be our final answer. However, if we look at the next example, we can't divide root of 5 by root of 2 because it doesn't reduce. It doesn't leave us with no radical in the denominator. And kind of the rule of thumb is you cannot leave radicals in the denominator. So in order to get rid of them, we kind of want to force that radical to be a perfect square. So in this case, the easiest perfect square to make our denominator would probably be root of 4. You could make it any other perfect square, but I like to keep numbers small. It'll prevent us from having to reduce at the end. So I'm going to multiply our denominator by root of 2. And what I do to the denominator, I need to do to the numerator as well. So again, when we multiply, because that's what we're going to do with our numerator, coefficients with coefficients, radicals with radicals. So there's a 1 there. I wrote it in. Normally it might be invisible. So in this case, we'd be left with root of 10 over, well, in our denominator, we'd have 5 root of 4. So from here, we'd simplify wherever we can. So root of 10, there's no perfect square that goes into that. So we would just be left with root of 10 over 5, and the square root of 4 is 2. So continue to simplify, root of 10 over 10. And at this point, you might be thinking, oh, well, 10 and 10, those are common. Those are the same number. We can divide, we can reduce. Well, no, you can't, because in our numerator, there is a radical. And so again, radicals with radicals, coefficients with coefficients. One other thing to note is in your example or the work that you're doing, after you multiply, so kind of in this first step, you could jump straight to the second step if you can do that. Like if you can see that pattern and you can get there, that is totally fine. I don't expect you to show the step in the middle, but if you're looking at ways to keep consistent, that might be a good idea. So our next example, we've got 2 root of 12 over 5 root of 20. So the first thing I might do here is I might look and say, oh, well, I've got 2, or in this case, even 4, is common in both of my radicals. So if I divide each of my radicals, I'm going to divide this by 4, and I'm going to divide this by 4. Technically, I guess I'd be dividing by root of 4, but potato, potato. So 2 root of 3 over 5 root of 5. So in order to get rid of that root of 5 in the denominator, I want it to be a perfect square. So easiest one, 25. So I'm going to multiply this by root of 5 and my numerator by root of 5 as well. Again, coefficients with coefficients, radicals with radicals. So in my numerator, I'm going to end up with 2 root 15 over 5. Again, technically, root of 25. You could skip this step and end up with 2 root of 15 over 5 times 5 right away. Again, I don't care which step you go to. Both are acceptable. And then from here, I'm going to go back up to the top because we don't work sideways. We work down the page. I'm going to have 2 root 15 over 25. Again, you're going to look for things that can reduce. 2 and 25, there's nothing common. Root of 15, there's no perfect squares that go into that. So this would be our final answer. Okay, so then our last example. So before we were dealing with perfect squares, the only difference here is we are dealing with cubes. So we want to have a perfect cube in our denominator then. Again, does not matter what perfect cube, but typically the smaller the better, just to keep our numbers nicer. So if we think of our list of perfect cubes, well, the easiest one would probably be 8. So I could either multiply this. There's 2 ways you could do this. You can multiply it by the cube root of 2 times the cube root of 2, because technically that's almost like cubing it then. But we know we want to get to 8. So, well, 2 times cube root of 4 is going to get me to 8. So 4 cube root 24 over, oh, okay, I see something we could have done, but for the sake of my point for how to do this, we're going to continue this way. 3 cube root of 8. So simplify where possible. In the numerator, a 8 goes into that. So I'm going to have 4 times 2, because I took the cube root of 8. And I'm left with 8 times 3. Quick maths. Over 3 times the cube root of 8 is 2. So here's kind of where my number could have come in handy. Notice we are multiplying by 2. In this step, so things you could do, you could go, okay, well, 8 cube root of 3 over 6. And then go, oh, well, 8 and 6 have a common factor. That's 2. Divide each by 2. And you'd be left with 4 cube root of 3 over 3. However, looking back at our original thing, notice 2 is a factor in each case. So if I divided each one by 2, I'm already left with 3 cube root of 3 over 3. So we got there in the end. Doesn't matter what way you do it, just showing you that there's lots of different ways. The thing I noticed back up in the question was that 6 and 2 have a common factor. I could have just divided, but for the purpose of this example, I wanted to demonstrate to you that how to deal with a cube. So yeah, that's it. That's all.